projects. In this video, we are going to explain about the project, which is Hybrid Information Mixing Module for Stock Movement Prediction. Introduction of the project. With the integration of deep learning technologies into the financial sector, particularly amid the COVID-19 pandemic's heightened stock market volatility, accurate stock price movement prediction has become crucial for effective forecasting. This project addresses the challenge of enhancing stock market forecasting by leveraging deep learning techniques. Traditional methods for stock price prediction have relied on technical analysis using historical price data and more recently on the text data such as news articles and social media posts. However, these methods often face limitations in capturing complex patterns that influence stock price fluctuations. The project proposes a novel hybrid approach that combines both price data and text data for more accurate stock price movement prediction. By leveraging deep learning models such as long short term memory, which is LSTM, gated recurrent units, which is GRU, and bidirectional encoded representations from transformers, which is BERT, the aim is to extract time series and semantic features that capture the unique characteristics of each data type. The extracted features from the price and text data are combined to create a mixed feature containing multi-model information. This mixed feature enhances the understanding of stock market signals by capturing the interaction between different types of information, thereby improving accuracy of stock price fluctuation prediction. To facilitate effective interaction between the two types of features, a hybrid information mixed module comprising two multi-layer perceptron blocks is proposed. This module strengthens the multi-model information contained in the mixed feature, enhancing model's ability to predict stock price movements accurately. The simplicity of MLP-based approach also offers computational efficiency compared to transformer-based models. Objective of the project. The goal is to develop a reliable forecasting method by harnessing the complementary insights offered by historical stock data and up to the minute news data, aiming to provide more accurate predictions of future stock price movements in dynamic market conditions. The objective is to incorporate market volatility as a pivotal factor within predictive model, recognizing its significant influence on stock price fluctuations, thus ensuring a more comprehensive understanding and representation of market dynamics for enhanced forecasting accuracy. The aim is to pioneer an innovative fusion technique that seamlessly integrates features extracted from both price and text data sources, thereby enriching the predictive capabilities of the model by capturing diverse market signals and information sources to better anticipate stock price movements. The goal is to construct a specialized module that facilitates effective interaction between time series features from stock price data and semantic features from news text data utilizing two map blocks for optimal integration. The objective is to apply a multi-layer perceptron-based model incorporating the design hybrid information mixing module for stock price movement prediction and evaluate the model's performance using metrics such as accuracy, precision, recall and FN score, and RMSE to assess its effectiveness in capturing stock market dynamics. To implement this project, we need software and hardware requirements. Coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to the hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement the project, we have designed various steps in the flow of work. So coming to the first step, which is importing the packages. This step involves importing necessary libraries and packages required for data processing, analysis, modeling, and deployment. Commonly used packages include Pandas for data manipulation, Matplotlib and Seaborn for data visualization, scikit-learn for machine learning tasks, TensorFlow and Keras for deep learning models, Flask for web application development, and SQLite for database management. Coming to the next step, which is exploratory data analysis. EDA involves exploring and understanding the dataset. This includes examining the structure of the data, checking for missing values, understanding the distribution of variables, identifying patterns and trends, and gaining insights into relationship between variables through visualizations and statistical summaries. The next step is data processing. In this step, the data is prepared for modeling by handling missing values, encoding categorical variables, scaling numerical features, and any other necessary pre-processing steps. This ensures that the data is in a suitable format for training machine learning or the deep learning models. Coming to the next step, which is feature extraction. Here we have used BERT, which is bidirectional encoder representations from transformers. It is a pre-trained language representation model that is used for feature extraction from text data. In this step, BERT embeddings are applied to convert textual input into numerical representations that capture semantic information which can be used as features for modeling. The next step is splitting the data into train and test. The dataset is divided into two subsets. One is training data and the other one is testing data. The training data is used to train the machine learning or the deep learning models, while the testing data is used to evaluate the performance of the trained models. Typically, the data is split in the ratio of 80 for training and 20 for testing. The next step is building the models. In this step, it involves in initiating and building the deep learning models. Here we define the parameters. The next step is training the models. The selected models are trained using the training data. During training, the model learns from the input data to make predictions or the classifications. The training process involves adjusting the model parameters iteratively to minimize the difference between the predicted outputs and the actual labels. The next step is Flask framework with SQLite for sign up and sign in. Flask is a web framework for building web applications in Python. In this step, a web application is developed using Flask and SQLite is used as a database management system for user authentication. Users can sign up for an account and sign in to access the application's functionality. The next step is user upload. Users are provided with the option to the upload ticker symbol of the companies for which they want to predict stock movements. Ticker symbols uniquely identify publicly traded companies and are used to retrieve relevant stock data for the prediction. The next step is pre-processing of the given input. The user provided input such as a ticker symbol of the companies undergoes pre-processing to ensure compatibility with the model's input format. This involves data validation, normalization, and encoding to transform the input into a suitable representation for prediction. The next step is using trained model for prediction. The trained deep learning model is deployed to make predictions based on the pre-processed input data. The model utilizes the extracted features and learned patterns to forecast stock movements for the specified companies. The last step is displaying the final outcome. The predicted outcomes, which represent the forecasted stock movements for the user selected companies, are displayed to the user via the web interface. This allows users to visualize the predicted results and make informed decisions regarding their investments and the trading strategies. Algorithms which are used for stock movement prediction are LSTM, which is long short term memory. It is an improved version of the recurrent neural network. LSTM is well suited for sequence prediction tasks and excels in capturing long term dependencies. Its applications extend to tasks involving time series and sequences. LSTM's strength lies in its ability to grasp and order dependence crucial for solving intricate problems such as machine translation and speech recognition. Unlike traditional RNNs with a single hidden state, LSTMs introduce a memory cell with three gates: input, forget, and output gates. These gates control the addition, removal, and output of the information from the memory cell, enabling the network to selectively retrain or discard information. This capability makes LSTM suitable for tasks like language translation, speech recognition, and time series forecasting. Additionally, LSTMs can be combined with the other architectures such as CNNs for applications like image and video analysis. In this project, LSTM is used for its ability to effectively model sequential data such as historical stock prices and the textual data from news articles. By leveraging LSTM, the model can capture temporal patterns and dependencies in the input data, which is crucial for stock price prediction. Additionally, LSTM's ability to retain long term memory makes it suitable for capturing trends and patterns in the time series data. The next algorithm is LSTM with GRU. Here, LSTM with GRU combines the LSTM architecture with the GRU architecture. Another type of gated RNN variant. GRU is a type of recurrent neural network, which is RNN. It is the simpler alternative to long short-term memory networks. Like LSTM, GRU can process sequential data such as text, speech, and time series data. The basic idea behind GRU is to use gating mechanisms to selectively update the hidden state of the network at each time step. The gating mechanisms are used to control the flow of information in and out of the network. The GRU has two gating mechanisms called reset gate and the update gate. The reset gate determines how much of the previous hidden state should be forgotten, while the update gate determines how much of the new input should be used to update the hidden state. The output of the GRU is calculated based on the updated hidden state. This combination of LSTM and GRU is employed in the project to leverage sense of both architectures. LSTMs excel at capturing long-term dependencies while GRU offers computational efficiency. By combining the two, models can potentially achieve better performance in terms of accuracy and efficiency for stock movement prediction tasks. As an extension, we have incorporated ARIMA, linear regression, and hybrid methods that combine LSTM and GRU and bidirectional processing. This diverse approach ensures a more robust and accurate final prediction, which has been applied on live data. Additionally, to facilitate user testing and interaction, we developed a front-end interface using Flask, complete with authentication features. This is allowed for seamless user engagement and validation of the predictive model performance in the real-world scenarios. We have used accuracy, precision, recall, and FN score, which are the performance metrics to evaluate all the models built in the project. So here we have comparison graph for all the models built in the project. In this graph, x-axis represents algorithm names and y-axis represents error rate. So here, blue color represents the accuracy, orange color is the FN score, green color is the precision, and red color is the recall. Now we will know what are these metrics. Coming to the accuracy, it is the proportion of correct predictions in a classification task measuring the overall correctness of the model's predictions. Precision is the ratio of true positive predictions to the total positive predictions, representing the model's ability to correctly identify any relevant instances while minimizing false positives. The next metric is recall. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring the model's ability to capture all relevant instances without missing any. F1 score is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making it suitable for imbalanced datasets. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be loaded in HTML templates. And this is the model file, which contains the algorithm information and that will be loaded into the project code during runtime. And this is the notebook.ipynb file. This is the Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the signup.db file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of File Explorer. So I'm copying the path. Now we have to open the Anaconda prompt. Using the command cd space, and now we need to copy the path. And now we need to click on enter. By giving this command, current directory will change to the code folder's path. Here we have to give the other command python space app.py to compile the app.py file. And now we need to click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. This is the local host and this 5000 is the port. Now we have to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is built using Flask framework. And here we can see a sign up link. First, we need to click on that. If we are new users, we have to fill up all these details to sign up and then sign in. I have already account, so I'll directly sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password, and now we need to click on sign in. and we are redirected to prediction page. Prior to the stock prediction of any particular company, we have to enter its ticker symbol. A company's ticker symbol is also known as a stock symbol or a ticker symbol. It is a unique series of letters or characters assigned to a publicly related company's stock. It serves as a shorthand identifier for a specific company's shares traded on stock exchange. Ticker symbols are typically composed of letters and sometimes numbers, and they are used by investors, traders, and financial professionals to quickly identify and track the performance of a particular company's stock in the market. So now we will do the stock movement prediction of a company Google, and its ticker symbol is GOOG. And here we can see a button called Go. We need to click on that. So here we got the stock movement prediction of the company Google, where it has predicted all these prices. So first we will know what these prices are. So the first price is opening price. Opening price refers to the price at which a stock started trading for the day, and the opening price of the Google is 144.21. The next one is high. High refers to the highest price reached by the stock during the trading day, and it is 144.48. The next one is low, which refers to the lowest price reached by the stock during the trading day, and the lowest price is 141.52. The next one is close, which refers to the final price at which the stock traded at the end of the trading day, and it is 141.76. Coming to the next one, which is adjusted close. It is the closing price of the stock adjusted for any corporate action such as stock splits or the dividends, and the price is 141.76. The last one is volume. It is the total number of shares of the stock traded during the trading day. Coming to the graphs, this graph represents recent trends in the Google's cryptocurrency prices, where x-axis represents the dates and the years, and y-axis represents cryptocurrency prices. Initially, in the 2022 fourth month, cryptocurrency prices were high. Later, it has fallen down, and then from 2023 fourth month, it has rising up to 2024 first month, it has reached to 150 cryptocurrency price. Coming to the next graph, which is ARIMA model accuracy comparison graph. This graph shows how well the ARIMA model predicted values. Here, the red color line represents actual price, which is actually what happened, and the blue color is what has been predicted, which is model predicted. Here we can observe that two lines are very close to each other, which means the model did a good job predicting. Coming to the next graph, which is LSTM by GRU model graph. Here also, red color line represents actual price and blue color represents predicted price. We can observe that there is difference between blue color and the red color, where there is a notable difference. Here we can consider that the model is not performing well. Coming to the next graph, which is linear regression graph. Here also, red color line represents the actually what happened and blue color represents what is predicted. And there is noticeable difference between two lines, suggesting that model's predictions vary considerably from the real values. And here, tomorrow's Google closing price predicted by ARIMA is 147.27, by LSTM GRU is 145.56, and by linear regression is 150.22. And the RMSE score of ARIMA is 2.52. By GRU, which is LSTM with by GRU is 4.61, and linear regression's RMSE is 6.66. We can consider that whose error rate is least, we can consider for it predicting. So ARIMA's RMSE value is least, which is 2.52. So we are considering for prediction. And the predicted Google price for the next 7 days is this. Now we will do stock movement prediction of the Tata company. For that, click on home. So the Tata company's ticker symbol is Tata ELXSI.BO. Now click on Go. So here we got the predictions of the company Tata, which is stock movement predictions. And here are the prices where opening price is 7,504.1 and the highest price is 7,742.35 and the lowest price is 7,515.45. Similarly, we have closing price, adjacent price, and the volume. Here we have recent trends in the Tata company's cryptocurrency prices, where x-axis represents the dates and y-axis represents cryptocurrency prices. Here we have ARIMA model's accuracy graph, where Red color line represents actual price and the blue is predicted price. And here both lines are very close to each other. It means that the model is performing well and it can predict well. Here we have LSTM's model accuracy graph. Here we can observe that red color line and blue color line are varying to each other, which means there is distance between these two graphs. So we can understand that these two, which is LSTM by GRU model, is not performing well. Similarly, linear regression also. And here, tomorrow's Tata company's closing price by the ARIMA model is 707,473.92, and the LSTM's by GRU predicted price is 7,380.3. Coming to linear regression, here we have 7,919.72. And here are the RMSE values of ARIMA, LSTM by GRU, and linear regression. And the lowest RMSE value of algorithms is ARIMA's. So here we have 124.79, which means that this model is performing well. And predicted Tata's price for next 7 days is this. Now click on sign out. In this way, we can do the prediction of stock of any company. Conclusion of the project. The novel fusion technique combining features from price and text data sources enhances the predictive capabilities of the model, capturing diverse market signals and information sources for more accurate predictions. Through the integration of the LSTM with GRU architectures, the project achieves improved accuracy in forecasting stock price movements, leveraging the strength of recurrent neural networks to capture temporal patterns in both numerical and textual data. The utilization of the LSTM and LSTM with GRU enables effective modeling of sequential data such as historical stock prices and news articles, allowing the model to capture intricate dependencies and trends crucial for accurate prediction. With the implementation of the Flask framework and SQLite database, the project offers a user-friendly interface for users to sign up, sign in, and upload company ticker symbols, facilitating seamless interaction and utilization of the stock prediction system. The extension algorithm, which is ARIMA, exhibited outstanding accuracy, delivering precise stock price movement forecasts with minimal error rates. Its reliability and robustness were confirmed through testing with the livestock data in the front end, providing users with actionable insights for informed decision making. By providing users with accurate predictions of stock price movements based on historical data and the real time news information and the live data, the project empowers investors and traders to make informed decisions, enhancing their ability to navigate dynamic landscape of financial markets.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.